All right, section 2 from chapter 6 is first order systems. And I don't feel like writing all this up, so I'll just look at it real quick. What is a first order system? A system of differential equations with unknown functions of t. x1, x2, xn, all of these are functions of t. It's called a first order system if it's of the form where you can rewrite the derivative of x1 in terms of t with respect to t as some function of t's and x1s, and then you can write the second um, or the first derivative of x2 as some other function, and the derivative of xn as another function. So if you can write them all where you can write the derivative of x2 in terms of t's and x's, then, well, and the x2's, right? So of the previous function. Yeah. For given functions f1, f2, fn defined on some interval I. A solution of the system is an ordered set of functions, x1 through xn, that satisfies the system on the interval. And then a set of auxiliary conditions of the form x1 of t naught is equal to k1 and x2 of t naught is equal to k2 all the way through kn, where all of these k's are given constants. These are called the initial conditions for the system. Okay, so I didn't want to write all that, but you feel free if you want to write all of that. Instead, I just wrote in my own writing, check out the notes because this is the form that we're going to need everything in, right? And what we want to do is we want to transform a system into this form. And we're going to use substitution to turn it into a first order system. And we'll solve algebraically for the highest derivative of each function. So let's just do an example and then hopefully you'll see it makes sense. All right, so first example is we want to rewrite as a first order system x1 prime minus 2x2 prime is equal to x2 plus t squared, and then x1 prime minus 3x2 prime equals 0. Those are our two equations, and they want us to rewrite this as a first order system. So the first thing I would do is right here, you can totally solve for one of these guys. So if I solved for x1 prime would equal 3 times x2 prime. Yeah. And then you can substitute that into this guy. Substitute. Yeah. So instead of x1 prime, I'll substitute it with 3x2 prime. All right, so when I substitute it into the first equation, instead of x1 prime, I'm replacing it with 3x2 prime. And then I still have a minus 2x2 prime, and that's equal to x2 plus t squared. All right, well, these two guys are like terms, so you can simplify that. 3 minus 2 will give you a 1x2 prime is equal to x2 plus t squared. And then I can substitute this into, maybe I use a different color. You're going to substitute this into that guy so that you get x1 prime would equal 3. Well, how about if I write it first? 3x2 prime. But then that means it's 3 times, and I'm substituting x2 plus t squared in there. So that's where I substituted in there. And then that means x1 prime is equal to 3x2 plus 3t squared. And so what I'm saying to you is the equivalent system but now that's a first ordered system is you've got to provide x1 prime would be 3x2 plus 3t squared, and x2 prime we said was x2 plus t squared. There you go. There's a first order system because now it's in the form of first order system. You need to have, x1 prime is equal to some functions of t's and x1s, 2's, xn's, right? And x2 prime needs to be some function in terms of t's and x1, x2, and all that. And so I've got functions of t's and x2's on all of them. It also says to indicate what must be given for an appropriate set of initial conditions. What you'll need is to solve to the initial conditions needed would just be x1 of t naught and x2 of t naught to be able to find needed to find a particular solution. It would just be those two guys. Okay, so that was a pretty straightforward one of just using substitution stuff. But you're going to see ones even more complicated, like this next example, where same directions, but it's x1 triple prime, so that's the third derivative of x1 minus first derivative of x1 plus x1 times the first derivative of x2 is equal to sine of t. And then the second equation is second derivative on x1 minus x2 times first derivative of x1 minus second derivative on x2 is equal to cosine of t. Okay, so what we're going to do is we're going to do some substitution of variables. I am going to, what you want to do is, what I noticed is on x1, my highest order derivative is the third derivative. And on x2, the highest order is the second derivative on x2. So what you need to do is I'm going to use different letters. I'm going to use that u1. I'm going to let u1 equal x1. I'm going to let u2 equal x2. I'm going to let u3 equal x1 prime. I'm going to let u4 equal x2 prime. And then I'm going to let u5 equal x1 double prime. And I stop there. And here's why. Because you're going to end up solving for the third derivative on x1. And so you just need 1 degree less. So that's why on x1, that's the third derivative. I only need to go to the second derivative on x1. For x2, I need to find the second derivative on x2. That's why I only needed to go to the first derivative on x2. So because of these replacement of variables. And you'll see when I write the answer why it makes sense. You stop 1 degree short of what you end up needing. And then we're going to rewrite the first equation. We're going to rewrite this first equation, replacing them with all of these guys, but first, solve for the highest order first. Meaning isolate the highest order. And in this case, it was the third derivative of an x1. So you've got x1, third derivative of x1, and then that's what I want to isolate this guy. So I'm going to add the x1 prime. I'm going to subtract the x1, x2 prime, and then I still have this sign of t on the right-hand side, and it was positive. So all I did was, on the first equation, I isolated the highest order of derivative, right? So I added, subtracted, and then you still have that. All right, and then we use these guys as my substitutions. I'm going to change everything into u's. So x1, the third derivative of x1. I don't have one, right? But that's okay, because the third derivative of x1 would be the first derivative of u5. And so it's u5 first derivative. So what's what you got to do with these first order systems is you're going to solve for each of these guys and go, okay, you're going to be like, okay, x1 prime is this guy. And anyway, well, we're going to have it in u's, but whatever. But you need all of them to be the first derivatives. Okay, so u1 prime, u5 prime would be x1 prime. Well, x1 prime I said was u3 minus, where did I say x1 is? u1. What did I say x2 prime is equivalent to? x2 prime is u4. And then plus sine of t. Yeah? We're going to do the same thing for the second equation. And again, you need to solve for the highest order. And the highest order on this guy is going to be, well, we already got x1 triple prime here, so we're going to go with x2 double prime is what I want to solve for. So I would add that guy over to the other side, but I'm going to write it like that. x2, the second derivative on x2 would be x1, second derivative on x1, minus x2 times first derivative of x1, and then I would have needed to subtract the cosine of t to get those over there. And then you do these substitutions, right? Well, I need the second derivative on x2. I don't have it, but that's because I'm going to just say it's the first derivative on u4. First derivative on u4, right? Because it would be the derivative of the first derivative would give you the second derivative. x1, second derivative on x1, we said was u5, minus x2, we said is u2. x1 prime, we said is u3, and then minus the cosine of t. And so, what is my equivalent system? The equivalent system, but now written as a first order system, is this. What's u1 prime equal to? It is u3. Since u1 was x1, u1 prime would be x1 prime, but we said it was u3. Make sure it's on the thing. u2, first derivative of u2. Well, u2 is x2, so the first derivative on x2, we called it u4. Yeah. u3 prime. The derivative on u3, well, we said u3 was x1 prime, and so the derivative of that would be the second derivative on x1, but we labeled that as u5. And then u4, first derivative on u4. Oh, look, I already got it right there, right there, right there. It's u5 minus u2, u3 minus cosine of t. And then last but not least, I got the first derivative on u5 would be u3 minus u1 times u4 plus sine of t. That is the equivalent. This is the equivalent system, but as a first order system where each of these guys are defined in terms of their first derivatives. What are the initial conditions needed? The initial conditions needed to find a particular solution would be, we would need x1 of t naught, you would need x2 of t naught, you would need x1 prime of t naught, you would need x2 prime of t naught, and you would need the second derivative on x1. It's all of the ones, sorry, I didn't realize it wasn't showing. It's all of the ones where if I can't get them both on the same screen, but all of those I let u1 equal x1 and u2 equal x2 and u3, like all of those, and I went through u5 was equal to x1 double prime. It's all of those. Those are the initial conditions that you need in order to solve it. Yeah? All right, let's do one more. I'll slide it back up. So these are these guys. Plugging in T naughts into all of these guys there, which so was one less degree on both of them. Okay. Last one. How about if it's the fourth derivative of x plus the third derivative of x times x minus the second derivative of x quantity squared equals 0. All right, so my highest order is x to the fourth. So that means when I go to do my substitutions, I'm going to go to the third derivative. So I'm going to let u1 equal just x. I'm going to let u2 equal first derivative on x. I'm going to let u3 equal the second derivative on x. And I'm going to let u4 equal the third derivative on x. And then we'll solve this equation for the highest degree. Or the highest order. So x, the fourth derivative on x would equal, and you'll add the second derivative quantity squared, but then subtract x, the third derivative of x times x. Yeah. All right. So I need the fourth derivative on, what did I write there? Sorry about that. I labeled that an x, and that's not an x, that's a u. I apologize. Sorry. So sorry. Okay, there we go. U4 is the third derivative on x. Okay, so if I want the fourth derivative on x, well, that means that it would be the first derivative of u4, because the first derivative would be the derivative of the third derivative. So this is first derivative of u4. Second derivative of x we called u3. And we're going to square it. And then minus third derivative we called u4. And x we called u1. So the equivalent system is u1 prime would be x prime, but that's u2. u2 prime would be the derivative of the first derivative, so it's the second derivative, we called it u3. u3 prime would be the derivative of the second derivative, which is the third derivative, so that one's u4. And then the first derivative of u4, we solved right there. It's u3 squared minus u4 times u1. What are the initial conditions you need? You need initial conditions for all of these guys. So the initial conditions needed to find a particular solution would be x of t naught, x prime at t naught, x, double prime at t naught and x, the third derivative. That's 3 of them at t naught. Sorry for the mess. That's t. Okay. I want to make one little note to you when you go to do the homework. Number 9 in the book matches number 7 in the solution manual, and number 11 in the book matches up with number 9 in the solution manual. So just be aware of that. Okay. There we go. Doo-doo-doo. Right. You all have a fabulous day. Bye.